Write the expected ground state electron configuration for the following. The element with one unpaired 5p electron that forms a covalent bond with the compound fluoride. If we look at a periodic table and look at the 5p orbital, it consists of these. We can see that iodide is the element that has one unpaired 5p electron because if we look at the electron configuration, which I wrote here, it has one unpaired electron. So, using noble gas configuration, so we start from Kr, the electron configuration would be Kr 5s2 4d10 5p5. However, indium also has one unpaired 5p electron, but it would create an ionic bond with fluoride instead of a covalent bond that iodide will. The as yet discovered alkaline earth metal after radium. So looking at a periodic table, the second column consists of the alkaline earth metals. And after radium, which is the last one, we have to find another one. So on this side of the periodic table, it's element 118, which means that over here would have to be element 119, then element 120. So given that it's element 120 that the question is explaining, electron configuration of element 120 would be Rn 7s2 5f14 6d10 7p6 and 8s2. The first row transition metal with the most unpaired electrons. Looking at the periodic table, this whole section is the transition metals, and within the first row, which is right here, the element with the most unpaired electrons would be chromium, because chromium's noble gas electron configuration is 4s1 3d5 and not Ar 4s2 3d4 like expected, because in its electron configuration, the last electron in the 4s orbital jumps to the 3d orbital at the end, leaving the noble gas configuration to be Ar 4s1 3d5. Use the values of enthalpy of formation in Appendix 4 to calculate delta H for the following reactions. This diagram represents the reaction of C2H5OH as a liquid plus 3O2 as a gas, which yields to 2CO2 as a gas plus 3H2O as a gas. Now we can look at Appendix 4 and identify all of the compounds that make up the reaction to put into the equation. Now that we have identified all the values of the compounds from Appendix 4, we can plug all this information into the equation up here. CO2 equals negative 393.5 kilojoules per mole, H2O equals negative 286 kilojoules per mole, C2H5OH equals negative 278 kilojoules per mole, and O2 equals 0 kilojoules per mole because its gaseous state exists naturally and is not a chemical reaction. So your equation should be delta H equals 2 times negative 393.5 kilojoules per mole plus 3 times negative 286 kilojoules per mole minus 1 times negative 276 kilojoules per mole plus 3 times 0 joules per mole, which simplifies down to delta H being negative 1,645 kilojoules per mole plus 278 kilojoules per mole, which equals, so delta H should equal negative 1,367 kilojoules per mole. CiCl4 as a liquid plus 2H2O as a liquid yields to SiO2 as a solid plus 4HCl aqueous. Now we can follow all the steps that we took for the last problem to figure out this problem. After looking at Appendix 4, we should have gotten that CiCl4 equals negative 687 kilojoules per mole, that H2O equals negative 286 kilojoules per mole, that SiO2 equals negative 911 kilojoules per mole, and that HCl equals negative 167 kilojoules per mole. Now we can plug all of these answers into this equation right here that we used for the last problem to find delta H. And you should have that delta H equals negative 911 kilojoules per mole plus 4 times negative 167 kilojoules per mole minus negative 687 kilojoules per mole plus 2 times negative 286 kilojoules per mole, which should have delta H equal negative 320 kilojoules per mole for your answer. MgO as a solid plus H2O as a liquid yields to MgOH2 as a solid. Now, following the same steps that we did for the last problem, in the problem before that, we find all of these compounds in Appendix 4. When you do that, you should get that MgO equals negative 602 kilojoules per mole. That H2O is negative 286 kilojoules per mole, like in the last two questions. MgOH2 equals negative 925 kilojoules per mole. Now, plugging this into the equation to find delta H, you should get that delta H equals negative 925 kilojoules per mole minus negative 602 kilojoules per mole minus 286 kilojoules per mole, which simplifies down to delta H equals negative 925 kilojoules per mole minus negative 888 kilojoules per mole, which equals that delta H equals negative 37 kilojoules per mole.